to students. In this video today we're gonna be learning how to solve exponential equations. Okay? Exponential equations. So obviously your heading will be solving exponential equations. Lesson 8.6 part 1. We're gonna have 2 videos over lesson 8.6. Go ahead and include today's date in your notes like I always tell you to do so that your notes are organized. We have really learned how to solve a lot of different equations this year, to be honest with you guys. I'm really proud of what you guys have accomplished. I'm not going to list them out, but going off the top of my head, we have learned how to solve linear equations, quadratic equations, radical equations, absolute value equations, absolute value inequalities, and I'm probably missing some. Have we done linear systems yet? I think maybe not. Don't remember for sure. I think we have. And now we're learning how to solve exponential equations. Okay, so really good job this year, and be proud of what you've done, guys. You've learned a lot, and we're going to continue to learn more. All right, here is what an exponential equation looks like. Okay, like usual, it can come in different many shapes, sizes, and assortments. Okay. But the main thing you need to know about an exponential equation is you're going to have an unknown in the exponent. Okay? It might look like this. It might have a parentheses and a -3 here. Your exponent might be x minus 4. That's okay. But the key to an exponential equation is are you ready? Your unknown. Or we call that your variable. Or we call that your letter, is in the exponent. Got it? Your unknown, or your variable, or your letter, is in the exponent. Okay? That's how you know you have an exponential equation. Now I'm telling you that because at the end of the year, when we have our big test, all these equations are going to be mixed up. You're going to have to look at each equation and decide what type of equation it is and then know how to solve it. Okay? So an exponential equation is an exponential equation because it has an unknown or a variable or a letter in the exponent. Okay? Okay, moving on. Before we get into learning how to solve these equations, I want to point something out to you that's kind of funny. You've already been solving exponential equations. You've already been doing it. Let me show you. Don't take notes on this, just watch, okay? If I asked you to solve this logarithm right here, you would set it equal to what, remember? X. Then you'd write it exponentially so it would look like this. Booyah, look at what you have. As soon as you took this logarithmic equation and you wrote it exponentially like this, you then had an exponential equation. How do I know that? Because of what I just told you. Your variable is an exponent. And you know how to solve this. 16 is the same thing as 2 to the 4th power. And so there we go. 2 to the 4th equals 2 to the 4th. X has to be 4. Now, the ones we're going to solve today are not even close to being that easy. You understand that? But I'm just trying to point out to you, you've actually already been solving exponential equations, and you didn't even know it. Okay? So as you can see, you've already been solving some simple exponential equations. Now, here are the steps that you will need. Here are the steps that you will need to solve these types of equations. They're long. You need to write them all down. They're going to sound like Greek to you. Okay? Greek. It looks like geek, doesn't it? Greek. But that's okay. Copy them down. You know I will explain them later, okay? Alright, here we go. Determine where the exponent and the base are, and then isolate them. Attempt to write both sides of the equation with the same base. By the way, that's what we just did back here. Just a second ago, that's what we did. Okay, right back here. Remember, I took this, and I set this equal to x. Then I went like this. Then I wrote the 16 with a base of what? 2, remember? So I wrote both sides with the same base. Well, that's what step 2 says to do. Attempt to write both sides of the equation with the same base like we've done before, okay? But, capital exclamation point, but if you can't write both sides of the equation with the same base, then do something new and something different. Take the logarithm sides. The base of the logarithm should be the same as the base of your unknown. I'll explain that later. Use your properties of logarithms to simplify the exponential part and then solve the equation, okay? Now I'm sure you gotta pause the video and copy this down. I'm gonna move on, okay? I think you will find these equations reasonable yet challenging, so be ready to think. Let's look at 5 examples, okay? 5 examples. I care about y'all, you know that. If you'll follow my steps, you will be okay. Here we go. Step 1. No, I've gone pretty fast, so I'm sure you've paused the video. Make sure you're ready to go. And here we go. Determine where the exponent and the base are, okay? Here's your exponent, the unknown. I'm going to circle it instead. There's your base right there, okay? What do you do to them? Isolate them. Well, guys, they're already isolated. There's nothing else on this side of the equation over here, is there? No. Now, if the equation looked like this, if it looked like that, here's your exponent, here's your base, you'd have 2 numbers to get rid of, the 2 and the -6, okay? But in this problem here, step 1 is already done for you. Here's your exponent, here's your base, they're already isolated, okay? Step 2, attempt to write both sides of the equation with the same base. Guys, students, dudes, there's no way. There's no way you can write both sides with an E or both sides with a 72 or anything like that, okay? So we cannot do that. Do you see that? In the problem I showed you about 5 minutes ago, we had this. Well, that's obvious. You can write the 16 like this. Can you not? Sure you can. You can write both sides with the same base. You cannot do that on this problem. Got it? Are you with me? Let's review. Determine where the exponent and the base are and get them by themselves on one side. Isolate them, excuse me. Attempt to write both sides with the same base. We can't do it. If you can't write both sides of the equation with the same base, then take the logarithm of both sides. Okay, no problem. Watch this. It's so easy. Put a logarithm here. Leave a little space. Put your equal sign. Logarithm here. We're going to take the logarithm of both sides. But hold it, guys. If you're going to take the logarithm of both sides, what base are you going to use? Well, it says right here, look. The base of the what? Do you see it? Logarithm will be the same as the base of your unknown. Well, here's your unknown right here. Got it? What was the base of your unknown? E. Is that not the base? Sure it is. Here's your exponent, here's your base. So every single time that you use step 3, whatever your base is right here, that's what you put right here. Isn't that easy, guys? Anyone can write the letters LOG, LOG, and then whatever the base is, you put it here and here. Got it? Now, the next thing you do is you bring down the entire left side. So it goes right here. Bring down the entire right side, it goes right here. Piece of cake so far, guys. Now I know it's new and it's a little, it's a little nerve-wracking probably. What are we doing here? But just watch, okay? I did it. I did step 3. What's step 4 say? Use the properties of logarithms to simplify the exponential part. Well, here's your exponential part. Look what we got here, guys. Look. Now you're seeing why I told you whatever this base here is, to put that base here, because look what it does for you. Look, you have matching bases. What if I taught you when this number here matches this number here, everything's gone except the what? Exponent. So you're left with an x right here. Cool. Okay. Do you now see why I told you to use this base right here for your logarithm? Well, Mr. Error, you can't just pick that out of the blue and use that. Yes, I can, as long as I do it to both sides, and I did it to both sides. Okay? So, these two numbers match, so everything's gone except the exponent. And then look what I have here. I have a logarithm with a base what? E. Do you see it? Now listen to me very carefully. I have taught you that your calculator does 2 types of bases when it comes to logarithms. When you have a base of what? 10. That's called a common log. And a base of what? E, that's a natural log. What button do you use for a common log? The button that looks like this. Remember, what do you use for a logarithm that has a base of E? This button right here, remember, natural log. So look what you've got. X equals log base E. That's the same thing as what? Natural log of 72. We learned that yesterday. Logarithm base E means natural log, or you can say natural log means logarithm base E. It's the same thing. So you're done. X equals what? The natural log of 17. So I'm reaching over right now. I'm grabbing my calculator and I'm typing in LN72, enter, and I'm done. You can round wherever you want to. 4.27, and then looks like 4 sixes. My efficiency's getting bad with old H here, and then 119. There you go. Not too bad. Let's do 4 more of these, okay? Let's practice, practice, practice. These steps right here are your lifeline to doing these correctly. Use these steps and you'll be fine. Okay, let's try another one. Alright, here we go. Don't skip any steps and don't go fast. Just take your time. Determine where the exponent and the base are. Okay, here's my exponent. Here's my base. What are we going to do to them? Isolate them. So there's a 5 I've got to get rid of right here, okay? Alright, so here we go. Let's get rid of the 5. Bring it over and make it a what? Negative 5. So now I have 10 to the x power equals what? 55. Now, is step 1 completed? Of course it is. My exponent and my base are what? Isolated. Step 1 is completed. Step 2. Attempt to write both sides with the same base. That's not happening, guys. There's no way you can write both sides with a base of 10 or a base of 55, okay? So on to step 3. If you can't write both sides of the equation with the same base, then do what? Take the logarithm of both sides. Got it? So I'm going to put the word log here, leave a little space, and log here. Now, the problem is what is my base going to be right here? Well, I've told you. Here's your unknown. What is the base of your unknown? 10, right? You see it? So that's the base you want to put here and here. Now, bring your entire left side down. Bring your entire right side down. And now you see why I use this base. Look what happens here. Use your properties of logarithms to simplify. Whenever this number here matches this number here, everything is gone except the exponent. X equals what? Now hold on, don't write anything, look. What is my base, guys? 10. That's a common logarithm. So I can just put logarithm of 55. You can put the 10 if you want to, but you don't have to. We can use our calculator for this. This button here will work out any logarithm that has a base of what? 10. So x equals this. So here we go. With your calculator, hit the logarithm button and 55, then enter, and you will get sorry guys, x equals 1.740362689. There it is. We did it. You can round wherever you want to. 1.7, 1.74, 1.740, 1.7404, whatever. Okay, but that's how you solve these. All right, let's move on. Let's get tougher and tougher and tougher. Okay, here's the next one. And by the way, the last two have been nice and pretty because your base was an E, thus a natural log, and your base was a 10, thus a common log. Not this one. So pay close attention, okay? Here we go. Step 1, let's determine where the exponent and the base are. Well, here's my exponent right here. 2x minus 3. There's the base. I'm going to isolate them, so I've got to get rid of this positive 4 right here, okay? I got to move it over to the other side. So bring it over. It becomes a negative 4. So I'm left with 5 to the 2x minus 3 equals 17. Now, is there anything else I have to get rid of? I don't think so. There's my exponent. There's my base. Step 1 is totally done. Step 2, attempt to write both sides the same base. Guys, it does not take an aeronautical engineer to see we're not going to be able to do that, okay? There's no way you can write a 5 and a 17 with the same bases. Step 3, take the logarithm of both sides. So I'll put logarithm here, leave a little space. Put a logarithm here, got it? Now, what's my base going to be for my logarithm? Well, look up here. What is the base of your unknown? Here's your unknown, here's your exponent. What's the base? 5. So what base do you put here? 5. What base do you put here? 5. Now bring this entire left side down. Bring this entire right side down. And there we go. Now, you've taken the logarithm of both sides. Now use your properties of logarithms. When this number here matches this number here, everything's gone except the what? Exponent. So I'm left with what? 2x minus 3 equals what? Now be very careful here. Don't write this. Listen to me. Guys, I hope that you've not forgotten what you learned about a week ago or so. Does your calculator do base 5s? Does it or not? No, your calculator does base what? 10 and base what? E. So remember what I taught you to do. You should know how to type these in. You have to type in the logarithm of what? 17 divided by the logarithm of what? 5. Y'all see that okay? Everybody see that? So, that's what I'm going to put right here. Instead of putting logarithm base 5 of 17, I'm going to put logarithm of 17 divided by logarithm of 5. That's the exact same thing, isn't it? Sure it is. This right here is the exact same thing as this right here. Okay? Now, let's slide this over and get some room here. It's about ready to get a little intense here. No, I'm just kidding. Let's get this. Let's get a little bit of space here. Now, I really don't like you guys to type this in yet. Right here and get a decimal until you have to, okay? I really don't. But, I really don't want you to do that. If you have to, it's fine. I'd like to leave it like this, okay? Now, if you'll look at step 4, I know my step 4 is up here, but it says, use your properties of logarithms. We did that right here. And then solve the equation. So all we have to do now is solve this. Get x by itself. So let's bring the negative 3 over and make it a positive 3, okay? So now we have 2x equals this whole expression right here. Plus 3. Everybody see that okay? Everybody got it? Do you see what I did there? Brought the 3 over, made it positive. Now, next step, divide everything by 2, right? So if I'm going to divide everything by 2, then I'm left with x equals, and then this whole thing right here, this whole thing here is going to be divided by what? 2. Now guys, that looks wicked. It's not. It's like it's nothing. It's a piece of cake. All you do is type in logarithm of 17, hit enter, then hit divided by logarithm of 5. Enter, then hit plus 3, enter, then hit divided by 2, enter, and you'll get the answer. The answer is 2.380. 187214. Let's go over this again. Clear your screen. Here we go again. Logarithm, type in logarithm 17, enter. Then divided by logarithm of 5, enter. And then plus 3, enter. And then divided by 2, enter. I like to hit enter a lot to make sure I'm doing this correctly. And this is the answer you will get. Back it up and watch again if you need to, guys, okay? Alright, let's try another one. Alright, here we go. Step 1. Determine where the exponent and the base are. Now be careful. Is the 0.2 your base? Is the 4? Well, let's see. Here's my exponent right here. What's the base? 4. This is not the base. 4 is the base. It's right next to the exponent. So I have to get rid of this number, and I have to get rid of this number. Okay? In order to do what? Isolate them. Okay? Everybody see it okay? This is my exponent. This is my base. Everything else I've got to get rid of. So here we go. Always save your multiplying number for last. See how this 2 is multiplying times the base. Always save that for last. Always. So bring the negative 16 over. And let's get a little bit of room to work here. Let's do this. You guys have the steps there in your notes, so I'm going to slide these up here and get some room to work. Okay. Bring the 16 over, negative 16 over, and make it what? Positive 16. So now we have 0.2 parentheses 4 x minus 1 equals 51. Everybody okay with that? Now next we're going to divide both sides by 0.2. To get rid of that 0.2, it's multiplying, so we're going to divide. Alright, these cancel, and I'm left with 4 to the x minus 1 power equals 255. Now is step 1 completed? Sure it is. The base and the exponent are isolated. Step 2, look at your notes there, you'll see it says write both sides with the same base. Not happening. Step 3, take the logarithm of both sides. So put a logarithm here, leave a little space. Put an equal sign, put your logarithm here. Here's your unknown, your exponent. What's the base? 4. So put a 4 here and a 4 here. Now bring this entire side down. Bring this entire side down. And now we've done step 3. We've taken the logarithm of both sides. Now use your properties. Whenever this number matches this number, everything is gone except the exponent. So I'm left with x minus 1 equals, now, is this a base 10? No. Is it a base e? No. So we have to write it like this. Logarithm of what? 255 divided by the logarithm of what? 4. There it is. Not too bad, guys. Now solve for x. So take this negative 1, bring it over and make it what? Positive 1. So we're good. With your calculator, type in logarithm 255, enter, divided by logarithm of 4, enter, and then plus 1. And you will get the answer. 4.997176718. Round wherever you want to, of course. Okay? One more and we're finished, guys. One more, okay? Here we go. Now this one here, we're going to be able to use step 2, okay? Alright, step 1, determine where the exponent and the base are and isolate them. We've got 1 on each side. Well, that's a little tricky, but at least this one's isolated over here. And this one's isolated over here, so let's move on. Attempt to write both sides with the same base. Okay, we can do that. I mean, can I write both sides with a 4? No, I cannot. Can I write both sides with an 8? No, I cannot. But I can write both sides with a 2. 2 squared equals what? 4. So for my 4 right here, I'm going to put 2 squared and then bring down my 3x. Now, 2 to the 3rd power equals what? 8. So for my 8 right here, I can put what? 2 to the 3rd power and then x plus 1. Okay? Now we're cruising right along. What if I taught you when you have a power raised to a power, you multiply those? So I have 2 to the what power? What about over here? I have a power raised to a power. So take your x plus 1 and multiply it by 3. That would be 3x plus 3. 3 times x, 3 times 1. Okay? There we go. So now I've written both sides with the same base, so I don't need step 3. I don't need step 4. Your bases are the same, so cross them off and set the exponents equal. So 6x equals 3x plus 3. Bring this 3x over and make it a what? Negative 3x, and you're left with 3x equals 3. Divide both sides by 3, and what does x equal? 1. Okay? And so, there we go. And if you were to put this 1 back up here, you would get out. If you put a 1 here for x and a 1 here for x, you would get 64 equals 64 for both sides, okay? Alright guys, that's it. I think that's it. Let's see. Is that the last slide? Yeah, that's it. Guys, I hope this has been a help to you. You need to know how to solve these. I've given you 18 homework problems, okay? So it's a lot of practice. It's good for you. You need that. If you have any questions, I hope this video's been a help to you. If you have any questions, don't hesitate to call or email.